This video is about 6E notes from the Unit 3 packet, solving absolute value equations. We'll be talking about the notes pages and select problems from each of the level worksheets. I expect you to try the problems that we work on together from each of the level pages, and then complete the level page that is from your level based on your pre-assessment. After you're finished with that, do the quizzes on Canvas relevant to this section. Recall solving linear equations. So 4/3 x plus 1 equals 13. The first thing you want to do is isolate the variable. Subtract 1 from each side. This is 0, and on the other side we have 12. So we have 4/3 times x equals 12. To get rid of the fraction, flip the fraction and multiply each side by it. Three-fourths times 4/3 is 1. So we have 1x on this side. On the right side, 12 divided by 4 is 3. And 3 times 3 is 9. X equals 9. And then on the number line, we'll just plot a point and call it 9. So we have a special piecewise function. The absolute value, written as f of x equals the absolute value of x, is defined as f of x equals the left side is negative x when x is less than 0. It's a sharp point, the vertex, if x equals 0. And then the right side is x when x is greater than 0. So basically, for each absolute value, we have a negative linear and a positive linear. So when you're solving absolute value equations, you're actually breaking it into two pieces and solving each one separately. The steps to solve an absolute value equation is in this box right here. First, you will isolate the absolute value. You will add or subtract the numbers outside of the absolute value, and then multiply or divide by the coefficient that may be in front of the absolute value, until you get something like this. We have the absolute value of some expression equals some other expression. Then you'll set up your two pieces, your negative piece and your positive piece. Solve each piece separately. Check for extraneous solutions if there is a variable on the outside of the absolute value. So if there's like an x right here, then you'd want to check your answer. If it gives you a real statement, a true statement, the solution is real. If it gives you a false statement, the solution is extraneous. So remember, from all those times that you checked your answer after solving, it wasn't just to check your work, it's actually to prepare you to check for extraneous solutions that will come up in some equations such as this one. Let's go over the examples in the table now. If you look at the first example, we have the absolute value of n equals 16. So you have your negative piece, n equals negative 16, and then you have your positive piece, n equals 16. You're already given the solutions here, so there was no steps needed, except for breaking it into the two pieces. So your solutions would be negative 16 and positive 16, plus or minus 16. Number 2, 9 times the absolute value of negative 9x plus 7 plus 18 equals 81. The first thing you want to do is isolate the absolute value. To do that, first we could subtract 18 from each side. And then divide by 9. We don't want to distribute here. We want to isolate the absolute value. So our isolated absolute value would be the absolute value of negative 9x plus 7 equals 7. Okay, next you want to set up your two pieces, your negative piece and your positive piece. Our negative piece would be negative 9x plus 7 equals negative 7. Our positive piece would be negative 9x plus 7 equals positive 7. We're only changing one side of the equation for our positive piece and our negative piece, not both. If you did both, it would cancel out what you just did. Okay, then you would solve for x on each one individually. So on the negative piece, x equals 14 over 9. For a positive piece, subtract 7, we have negative 9x equals 0. Divide by negative 9 on each side. We have x equals 0. We don't have to check for extraneous because there's no variables on the outside of our isolated absolute value equation. Okay, the next one we have the absolute value of x minus 17 equals 3. The absolute value is already isolated, so we don't have to do anything over here. Now we'll set up our positive piece and our negative piece. So for our negative piece, we have x minus 17 equals negative 3. And then for our positive piece, we have x minus 17 equals positive 3. Okay, let's solve for x for each individual piece. For the negative piece, let's add 17 to each side. So x equals 14. For the positive piece, we'll add 17 to each side. X equals 20. So for each side, we added 17 for the positive piece and the negative piece. So our solutions are 14 and 20. We don't have to check for extraneous because for our isolated absolute value equation, there's no variables on the outside, only the inside. Okay, on the next one we have absolute value of negative 19v equals 19. It's already isolated, so we're done with this first part. We'll do our negative piece and our positive piece. Our negative piece would be negative 19v equals negative 19. Our positive piece would be negative 19v equals positive 19. Again, you only change the sign for the negative piece on one side of the equation, not both. Okay, let's solve for v. For the negative piece, divide by negative 19 each side. So I have 1v equals 1. And then for the positive piece, we also divide each term by negative 19. So I have 1v equals negative 1. We don't have to check for extraneous because there's no variables on the outside of the absolute value. So our solutions are negative 1 and positive 1. Alright, let's look at example 5. The absolute value of d divided by 10 equals 3. The first thing you want to do is isolate the absolute value. To get rid of that divide by 10, we're going to multiply by 10. So then we have the absolute value of d equals 30. Set up our two pieces. So we have d equals negative 30. And then our positive piece. d equals positive 30. our solutions are negative 30 and positive 30. There's no variables on the outside. And also, your absolute value, when it's isolated, is positive on the right side of the equation. So that's why we don't have to check for extraneous. Let's look at the next one. Negative 1 minus the absolute value of m equals 19. The first thing you want to do is isolate the absolute value. To do that, we're going to add 1 to each side. We have negative absolute value of m equals 20. Divide each side by 1, or negative 1. So we have the absolute value of m equals negative 20. Now, the absolute value can never be a negative number, so this is always going to be false. Since it's false, even if you were to solve the negative and positive pieces, those would be extraneous solutions. So there's no real solution, the empty set. Let's look at the example 7. We have two absolute values for this one. The absolute value of 3x minus 9 equals the absolute value of x plus 1. Well, the first thing you want to do is write your two pieces, your negative piece and your positive piece. The negative piece would be 3x minus 9 equals negative parentheses x plus 1. You're basically going to multiply the entire right side of the equation by negative 1, not just the first term, but the whole thing. For the positive piece, we just take away the absolute value signs. 3x minus 9 equals x plus 1. Solve for x on each of these. So let's solve the negative piece. Distribute that negative 1 into each term. We have 3x minus 9 equals negative 1x minus 1. Add 9 to each side. We have 3x equals negative 1x plus 8. Add 1x to each side. So we have 4x equals 8. Divide each side by 4. Gives you 1x equals 2. And then let's solve for x on the positive side. Add 9 to each side. We have 3x equals 1x plus 10. Subtract 1x from each side. 2x equals 10. Divide each side by 2. X equals 5. So there's no negative constants on the outside of here. And there's no variables on the outside of the absolute value, so these are two real solutions. So your solutions are 2 and 5. Let's look at this one. So we have the absolute value of x plus 5 equals 3x minus 7. The absolute value is already isolated on one side, so we could go ahead and set up our two pieces, our negative piece and our positive piece. So for our negative piece, we have x plus 5 equals negative parentheses 3x minus 7. And then for our positive piece, we have x plus 5 equals 3x minus 7. Now we will solve for x for each one individually. Let's distribute that negative 1 to each term to get x plus 5 equals negative 3x plus 7. Subtract 5 on each side. X equals negative 3x plus 2. Add 3x to each side. A 0x on that side. We have 4x equals 2. Divide each side by 4. This fraction can reduce to 1/2. So x equals 1/2. Now let's solve for x on the other piece. Let's add 7 to each side. So x plus 12 equals 3x. Subtract 1x from each side. So I have 12 equals 2x. Divide each side by 2. You get 1x on one side and then 6 on the other. X equals 6. Now notice there is a variable on the outside. So that means we have to check for extraneous. So let's check the negative solution first to see if it's true or false. So we have the absolute value of 1/2 plus 5. Is it equal to 3 times 1/2 minus 7? 5 is the same thing as 10 over 2. Then we have 3 halves minus 7 is the same thing as 14 over 2. Okay, is 11 halves, the absolute value of that, the same thing as negative 11 over 2? Well, the absolute value is always going to be positive here. 11 halves is not equal to negative 11 halves. That's false. So x equals 1/2 is extraneous, which is the same thing as 0.5. Now let's check for the positive piece to see if it's true. Alright, so we have absolute value of 6 plus 5. Is it equal to 3 times 6 minus 7? The absolute value of 11, is that equal to 18 minus 7? 11 is equal to 11. So that's true. That means that x equals 6 is real. Let's do one more example where we have extraneous solutions, or where we need to check for extraneous solutions. So we have the absolute value of 2x minus 3 equals 3x minus 2. You want to set up your two pieces. So your negative piece would be 2x minus 3 equals negative parentheses 3x minus 2. And then your positive piece would be 2x minus 3 equals 3x minus 2. Alright, let's go ahead and solve for x for our negative piece. Distribute that negative 1 to get 2x minus 3 equals negative 3x plus 2. Add 3 to each side, so 0. 2x equals negative 3x plus 5. Add 3x to each side. 5x equals 5. Divide each side by 5 to get the x by itself. 1x equals 1. Okay, now let's do our positive piece. Let's add 2 to each side. So 2x equals, or 2x minus 1 equals 3x. Subtract 2x from each side. Negative 1 equals x. Now notice that our isolated absolute value equation has a variable on the outside. That means you have to check for extraneous solutions. Let's first plug in our negative piece's solution, see if it's true or false. So 2 times 1 minus 3. The absolute value of 2 times 1 minus 3 is equal to 3 times 1 minus 2. Is the absolute value of 2 minus 3 equal to 3 minus 2? Is the absolute value of negative 1 equal to 1? Yes, 1 does equal 1. The absolute value of negative 1 is a positive 1. That's true. x equals 1 is a real solution. Now let's check what x equals -1 for a positive piece's solution. Absolute value of 2 times -1 minus 3, is that equal to 3 times -1 minus 2? The absolute value of -2 minus 3, is that equal to -3 minus 2? Is the absolute value of -5 equal to -5? No. 5 is not equal to -5, so this was false. X equals -1 is the extraneous solution. Now we'll go ahead and go over some select problems from the practice worksheets. I expect you to try a few from each of the level pages, the ones we go over, but you only need to complete the one for the level that you're on for 6E. Refer back to your pre-assessment for 6E to see what level you are. Let's look at the 6E Level 1 worksheet, number 4. We will solve the equation and show all the algebraic steps. We have the absolute value of b plus 7 equals 14. First thing you want to do is isolate the absolute value. To do that, we're going to subtract 7 from each side. Absolute value of b equals 7. Set up your positive piece to your negative piece. Your negative piece would be b equals -7. Your positive piece would be b equals +7. So your solutions is either negative or +7. We don't have to check for extraneous because there's no variables on the outside, and also our isolated equation has a positive on the other side of the equation. So this would be our answers. Let's look at number 10 on the same worksheet. Absolute value of a over 3 equals 2. The absolute value is already isolated, so we'll set up our negative piece and our positive piece. Negative piece, we have a over 3 equals -2, and then our positive piece would be a over 3 equals +2. Okay, solve each one. We'll multiply each one by 3. And then we get our two solutions. A equals -6 or a equals +6. So your solutions is plus or minus 6. And remember, there is a key in the back of this packet to check your work. You still need to show all these algebraic steps, though, to get the credit. Let's look at the 6E Level 2 worksheet. Number 2. -5 minus absolute value of n divided by 2 equals -3. First thing you want to do is isolate that absolute value. To do that, add 5 to each side. So then we have negative absolute value of n over 2 equals 2. Divide each side by -1. So we have the absolute value of n over 2 equals -2. We can stop here because the absolute value is never going to equal a negative number, so it's no solution. If you were to solve for n, both of the solutions would be extraneous. Notice the circle with the slash in it, the empty set. That's not 0. That just means that there's nothing there. No solution at all. Alright, let's look at number 7 on the same worksheet, the level 2 worksheet. We have 3 times the absolute value of x minus 3 equals 18. The first thing we want to do is isolate the absolute value on one side. To do that, add 3 to each side. We have 3 absolute value of x equals 21. Divide each side by 3. Do not distribute. Absolute value of x equals 7. So this is your isolated equation. Set up your negative piece and your positive piece. We have x equals negative 7, and then x equals positive 7. There's nothing left to do from there, so your solutions is plus or minus 7. Alright, let's look at the 6E Level 3 practice worksheet. And let's look at number 6. So we have the 3 times the absolute value of 2m minus 5 equals 21. The first thing you want to do is isolate the absolute value. To do that, we're going to divide each side by 3. Do not distribute, just divide them out. So I have absolute value of 2m minus 5 equals 7. Okay, now you have your isolated absolute value equation. Set up your two pieces. Your negative piece would be 2m minus 5 equals negative 7. And your positive piece would be 2m minus 5 equals positive 7. Solve for m for each equation. And we get m equals 6 and m equals negative 1. You won't have to check for extraneous because there's no variables on the outside of your isolated absolute value equation, and this 7 is positive. So we'll go ahead and write those on the blanks. So we have a real solution for m equals negative 1 and a real solution for m equals 6. Let's look at number 8. The absolute value of x plus 6 equals 2x. The absolute value is already isolated, so let's go ahead and set up our negative piece and our positive piece. Our negative piece would be x plus 6 equals negative 2x. And your positive piece would be x plus 6 equals 2x. Now we'll solve for x for each equation. Subtract x from each side. So we have 6 equals negative 3x. Divide by negative 3 each side. Negative 2 equals x for your negative piece. Now for your positive piece, subtract x from each side. 6 equals x. Notice there's an x on the outside of our absolute value, so you need to check for extraneous. Let's check our negative piece's solution first. So is the absolute value of negative 2 plus 6 equal to 2 times negative 2? Is the absolute value of 4 equal to negative 4? No. So this is extraneous. So on number 8, for the negative piece, x equals negative 2 is extraneous. Now let's do the positive piece. Is the absolute value of 6 plus 6 equal to 2 times 6? Is the absolute value of 12 equal to 12? Yes, that's true, so it's real. So x equals 6 is a real solution. Now let's look at a couple of problems on the 6E Level 4 worksheet. Let's look at number 4. Negative 1 plus 7 times the absolute value of 8 plus 3r equals 153. The first thing you want to do is isolate the absolute value. To do that, we're first going to add 1 to each side. So we have 7 absolute value of 8 plus 3r equals 154. Divide each side by 7. 22 equals the absolute value of 8 plus 3r. Now let's set up our two pieces, our negative piece and our positive piece. Our negative piece would be 8 plus 3r equals negative 22. And our positive piece would be 8 plus 3r equals positive 22. Solve for each piece. So let's subtract 8 from each side. So 3r equals negative 30. Divide by 3 each side. R equals negative 10. And then for a positive piece, let's subtract 8 from each side. So 3r equals 14. Divide by 3. That fraction can't reduce. So we have r equals 14 over 3. We don't have to check for extraneous because this isolated absolute value doesn't have a variable, and also it equals a positive number. So we'll write the solution set, negative 10 and 14/3. Let's look at number 8. 3 halves times the absolute value of 1 plus 3/4 n plus 29/7 equals 50 over 7. So the first thing we'll do is isolate the absolute value. Let's subtract 29/7 from each side. These have the same denominator, so you could just subtract 50 minus 29. (21 over 7 is the same thing as 3. To get rid of this fraction on the outside, we're going to flip the fraction and multiply each side by it. The 3 divided by 3 is 1. 1 times 2 is just 2. So our isolated absolute value would be 1 plus 3/4 n equals 2. Now we'll set up our two pieces, our negative piece and our positive piece. And then we'll solve for each. So let's subtract 1 from each side. 3/4 n equals negative 3. To get rid of the fraction, flip the fraction and multiply each side by it. This is 1n equals negative 3 divided by 3 is negative 1. Negative 1 times 4 is negative 4. And then we'll solve for the other end. Subtract 1 each side. 3/4 n equals 1. To get rid of the fraction, flip the fraction and multiply each side by it. This is 1, so 1n equals 4/3. So those are your two solutions. Okay, let's look at number 9. We have 6.8 times the absolute value of x plus 1.4 plus 7.2 equals 27.6. The first thing you want to do is isolate the absolute value. To do that, let's subtract the 7.2 from each side first. So there you have 6.8 times the absolute value of x plus 1.4 equals 20.4. Divide each side by 6.8. And that will get you 1 on this side, and then this would be 3. So the absolute value of x plus 1.4 equals 3. Now you want to set up your two pieces, your negative piece and your positive piece. Solve for x on both. So we'll subtract 1.4 from each side. If x equals negative 4.4. And then we'll subtract 1.4 from each side on the other one. x equals 1.6. There's no extraneous solutions to check here, so these are both real solutions. Again, complete the worksheet that is for the level that you're on. You could do more of the practice as well if you would like some extra points. But do not forget to do your cherry quizzes on Canvas. So do the cherry quiz associated with 6E right now after you finish the worksheet. And then you'll do your checkup quiz for 6E next time.